Okay, we're gonna go ahead and get started. Hi everyone, happy Earth Day. Thank you for joining us. My name is Anna Renkert. I'm the Development and Engagement Manager at Massachusetts Rivers Alliance. Thank you for joining us today for this special Earth Day webinar titled Toxic Relationships, Investigating Aging Dam Infrastructure Near Contaminated Waste Sites Across the United States. A few quick housekeeping items. First, this session is scheduled to end at 1 p.m. Second, if you have questions as we're going through, please go ahead and put them in the Q&A feature at the bottom of your screen, which we will be tracking, or you can hold them until the last about 20 minutes for the question and answer session. Third, note that this webinar will be recorded and will be made available on the Mass Rivers YouTube channel. This webinar is about an investigation from Undark magazine about the catastrophic failure of the Edenville Dam in Michigan in 2020 that flooded a Superfund site downstream, along with 81 other aging dams around the country that could also threaten toxic waste sites if they were to fail. Our speaker will discuss the project and how to gather information about dams from state and federal officials. And now I'm delighted to introduce our speaker today. James Dinneen is a science and environmental journalist from Colorado based in New York City. He's currently working on a book project for Viking about Earth's deep interior. You can keep up with his reporting on Earth science and other curiosities by subscribing to his free newsletter, which we will put a link to in the chat. I will now hand it over to James to begin. Go ahead, James.
So much, Anna. Happy Earth Day, everybody, and thanks for having me. I'm really excited to talk to you about this story and about dams. Um, I'll just jump in with the outline of what this is going to look like today. First, I'm going to talk about some background around this story, how the investigation happened, how I first became interested in dams, and in this particular question of the relationship between dams and contaminated sites around the country. I'll talk about how we did that investigation, how we went about finding sort of risky sites, what we found, and I'm also talk about some tips on researching dams, how to use the federal and state databases that exist to learn information about dams of concern or interest. And then I'll talk a little bit about something you probably have heard before, the three R's related to dams of concern. And then I'll be happy to take some questions. Um, this picture on the right side of the screen is the Oroville Dam in California, which is I think the highest dam in the country, really big reservoir. And in 2017, there was a dam failure scare there because of overtopping in the spillway. The spillway broke down, and like more than 100,000 people had to be evacuated. The dam did not fail, but it shows some of the things we're concerned about here. Um, Okay, so here's where things started. So May 19th, 2020, I was in Colorado, living at home in the middle of the pandemic, and I came across some news about this dam breach and flooding that happened in central Michigan. Relatively small dam called the Edenville Dam started overtopping and then breached after heavy rains. It was a now 100-year-old hydroelectric structure on the Tittabawassee River. And somebody actually captured the breach of the dam on video. I'll play that here. There we go. There's the rush. Yeah, so you can see scary stuff. That dam breach created a flood wave that came down the river, became a torrent, snapping trees and telephone poles as it rushed past towns. It submerged entire houses further downstream. Um, and then about 10 miles and 2 hours later, the flood wave hit a second aging dam, the Sanford Dam, which damaged the spillway there, overtopped the dam, and then also breached the embankment of that dam. You can see here what the flood wave did to a road and bridge as it came down the river. Another 10 miles further downstream, the flooding entered the city of Midland, um, basically flooding the downtown of the city. It also caused a major Dow chemical plant that was flanking the river to have to shut down. Um, and that created a lot of concern about chemical releases from the plant. Fortunately, it looks like everything was okay there. But another concern was that that entire part of the river, like for like 50 miles downstream of the plant, was actually a Superfund site, which is the designation that the EPA reserves for the most severe contaminated sites in need of a cleanup. Um, for decades in the 20th century, Dow had dumped waste laden with dioxin from the plant directly into the river, which contaminated dozens of miles of sediment downstream all the way out into Saginaw Bay and Lake Huron. And dioxin is a carcinogenic material. One example of dioxin is Agent Orange, the herbicide used in the Vietnam War. So big problem, a lot of money and decades spent to clean it up. A lot of that contaminated sediment had been capped on the bottom of the river or around it. And in designing it, the engineers had accounted that for flooding from the river, but nobody had planned for the specific impacts of flooding caused by a dam failure and the sort of intense flood wave and scouring that can happen in that context. And so the worry then was that this flood wave from the failure of the two upstream dams could uncap the contaminated sediment and then spread them out onto the floodplain, creating another toxic disaster. Sometimes people talk about it like a toxic cascade, um, in the same way that the dam failure was a sort of cascade of failures, as can sometimes happen. So I read about all this very concerning stuff, and I was wondering, could this be true anywhere else? Is there anywhere else where a dam failure uh, might be threatening a contaminated waste site in some way that has been overlooked by the dam safety and also environmental protection officials who are supposed to be watching out for this stuff? And I started looking into it, and it became clear to me that this was just like not a connection that had been made. There's sort of silos of dam safety world and of environmental cleanup world, and they they hadn't sort of connected the dots. Um, so that was the start of this investigation. Um, the first thing I learned, which was news to me, I'm sure not news to you, but there are a lot of dams in the United States. The National Inventory of Dams, which is maintained by the Army Corps of Engineers, lists 92,591 dams right now. These dots on the map show those dams. There's so many, it's like solid color in some places. That includes everything from the enormous Hoover Dam, Glen Canyon Dam, to small farm ponds, irrigation dams and such. Some statistics about all these dams. The average age of them is 65 years, which is pretty old. A lot of dams sort of need repairs or need upkeep after 50 years. Many dams are 100 years plus older, like the Edenville Dam that failed. Only about 3% of these dams have hydropower, or produce electricity. 6% of them are regulated by the federal government. 71% of them are regulated by states, and then the rest are either privately owned or too small to be regulated. Um, about 17% of these dams, 15,000 dams, have what's called a high hazard potential rating. This is an important concept. It means that if the dam were to fail, it would be likely that some human life was lost. High hazard is often confused to suggest that it's high risk. It doesn't mean high risk. It doesn't mean that the dam is likely to fail. It just means that if it were to fail, it would be it would likely be deadly. Um, and uh, this has changed recently, but a report a few years back, before information on the on the quality of the dams or their sort of state of repair, uh, more than 2,000 of the dams in the database were both high hazard, so big enough to be dangerous, but also in poor or unsatisfactory condition during their most recent inspection. And those are the dams that did have inspections. Some of the dams haven't been inspected in a long time. Um, so once we knew where the dams were, the next question was to find, okay, where are there dams near the sort of most contaminated sites across the country? So this map shows is from the EPA and it shows all of the Superfund sites, both uh, ongoing, closed, and somewhere in between all over the country. And it also includes something called RCRA sites, which is like Superfund, but a different program. And we looked at 5,695 of these sites all across the country. Um, and Here, I just want to say my collaborator on this project, Alexander Kennedy, was really key. He was sort of the data person and GIS person, and so really enabled us to bring together these two different data sets. He's now a graphics designer at Chemical and Engineering News, doing some great stuff there. I should also say that this whole investigation was supported by a grant from the Society of Environmental Journalists. So thanks to them for that. So in simplified form, here's what we were trying to do. Here are all the high hazard dams. You can see the sort of in the like brownish orange color on the map. Those are high hazard dams. The blue green ones are the ones that are not high hazard. We were trying to see where are those dams near those contaminated sites. Um, so as you can see, that it's a complicated question. There are a lot of dots on the map. So to narrow our search, we selected dams that sit 6 or fewer miles away from the contaminated site. And then to narrow down further, we from that subset, we picked out dams that were in satellite images upstream of one of the toxic waste sites. Um, I'm sure there would have been a faster AI powered way to do that, or some sort of complicated way of using elevation to assess the hydrology there. But we did it in a very sort of like we just like looked at a lot of satellite maps and was like, is this river connecting the dots here? It seems like it is, to get to our list. And that identified several hundred dams that met those criteria. So high hazard dams that were upstream of a major contaminated waste site, within 6 miles. Um, Experts we spoke to said that many of the dams would flood much farther than 6 miles downstream, but we just had to choose that to kind of narrow the scope of our look. Like if you think about the Edenville Dam, that flooded, 20 miles plus downstream, so it could be much wider. But we had to start somewhere. Um, the next question though is okay, so we've done this kind of like eyeball napkin math analysis to say, okay, there's this dam here next to this contaminated waste site. That seems concerning. But how do we know that a dam failure would actually flood that site? Um, Understanding the inundation zone, it's called, of where a dam would fail is a complicated hydrological analysis problem that takes some serious science. The good news is there's something called an emergency action plan. So high hazard dams are required to produce emergency action plans that contains information on things like if failure at the dam seems imminent, here are the numbers you should call. Here are the places that have to evacuate. It focuses on things like, is there a hospital or a school in the inundation zone of the dam, like high priority areas to get people out of the way in this like worst case event. And a key part of the emergency action plan is a inundation map, which is often pretty sophisticated modeling to understand where a dam, if it were to suddenly fail and its reservoir were to empty out, where would it flood? Um, you can see two here. This one on the left is from a dam in Virginia, and you can see there's sort of like the yellow area and the red area. Those show the different areas that would flood depending on how much water happens to be in the would happen to be in the reservoir during the failure. But they range in sophistication. You can see on the right that is a inundation map from Tennessee, which looks to be drawn on with a highlighter, which it could still be totally accurate, but it ranges. And that's for the dams that have inundation maps or emergency action plans. Um, According to the NID database, currently just 77% of high hazard dams have an emergency action plan of any kind. They're all required to have one, but so about a fifth of dams that are big enough to be dangerous um, have no emergency action plan in place. Um, Even 77% is better. It's higher than it was, and there's been a lot of effort to try to get more coverage there. But in Massachusetts, that could be an interesting question to look at: is where are there high hazard dams that don't have an emergency action plan, and figuring out why not, who's responsible for making one, maybe make one. Um, so the other problem for us is that these emergency action plans are not public um, information. The inundation maps in particular, my understanding is that a lot of that rule to make this information not public came after September 11th, 2001, and was made not public because of concerns about terrorism risks related to dams and flooding. Um, and it is possible to get access to them via Freedom of Information Act requests, which is what we did. What makes that really difficult, though, is the patchwork of management for the country's dams, which I'm sure you've run into in your work in the state of Massachusetts. But dams are managed by a whole panoply of organizations. There's different federal agencies like the Federal Energy Regulatory Commission, the Army Corps of Engineers, the Bureau of Reclamation. Um, then also every single state has its own state dam safety agency that's managing dams there. There are private owners and public owners, and it gets complicated quickly. So we had to submit these Freedom of Information Act requests to literally every state, all these agencies. I went in person to the New Jersey Department of Environmental Protection to look at paper versions of these maps, which is the only way they would let us see them. And basically see, okay, in the area of the flood, is this contaminated site there or not? We were able to get this inundation modeling information for 153 of the 259 dams that we identified in our initial search. Um, the reason why we couldn't get all of them, for 63 of the dams, state or federal officials redacted information or declined to provide it, citing national security concerns. For 31 of the dams, the agencies said that they didn't have inundation maps prepared, so they didn't know. Um, just to visualize what I'm talking about here, here's an example from Greensville County, Virginia. So that red line is the 113-year-old Emporia Dam, which is a hydroelectric dam that's partially owned by the city. And then you see that blue blob on the right is the Emporia Foundry, which has a landfill that's full of lead, arsenic, and cadmium. More than 3,000 people live within a mile of that site. And the greenish area around it, that is the inundation area if the Emporia Dam were to fail. So the Emporia Foundry, which is outside of the floodplain of the river, is inside the floodplain of the inundation zone of the dam. And officials I spoke to at both the state environmental protection agency, but also state dam officials, had not considered this risk or link between these things, just like everywhere else. Um, so overall, this whole complicated analysis, we turned up 81 high hazard dams that had a major contaminated site within their flood zone. None of the dam safety agencies we spoke to knew about this particular um, risk or had looked at it. Um, and this is, it's a number, but you can see just the number of dots on the map. Like, this is not a comprehensive analysis. There are definitely others that would meet these criteria, but because of, we only looked at that 6 mile radius to narrow this down, these are the ones that we were able to find um, via this approach. You can see there's sort of a cluster in the Northeast. Uh, a lot of that is because of the history of industrialization, both related to damming rivers, but also to industrial contamination and population density. There are more people living in the Northeast than there are in the West. Um, so I thought it would be interesting because you are all in Massachusetts to look at there were three from those 81, there were three dams that popped up on our list in Massachusetts. The Chartley Pond Dam, the Eagle Lake Dam, the Indian Orchard Dam, and then each of these uh, names below them is the name of the contaminated site or RCRA site in the inundation zone of that dam. Um, so these could all be interesting to look at, understand who owns them. You could ask the Massachusetts Department of Conservation and Recreation for more information about them. That's the Massachusetts department that is responsible for dam safety in the state. Um, and I thought we could look briefly at the National Inventory of Dams itself, which is a kind of amazing database that has improved its transparency and also its ability to use, even just since this investigation happened. So I will go here to, can you see this okay? Okay, great. So this is the National Inventory of Dams. It's just publicly available. You don't need a account or anything to see it. It has every single dam in the country represented. Um, so here on the left, you see you can put in which state. So we're looking at Massachusetts. And then, whoa, it will show every dam in Massachusetts. You click browse these dams and it will show them all laid out like this. You can click on any one to get particular information. So if we wanted to look at Chartley Pond Dam, which was the one on the list, every dam has an NID ID. So and this is important because sometimes dams actually have the same name. So if you're looking for a particular dam, it's better to use the unique ID than to use the name. So I just copy pasted that here and I update the results. And oh, if I take these off, okay. So I just put in Chartley Pond Dam NID. It shows me where it is. You can see it here. You can see the reservoir, Chartley Pond behind it. So then I click here to get more information about it. And it tells me a bunch of interesting stuff about this dam. So you can see the owner, the town of Norton owns the dam. Its purpose is recreation. So I assume, people fishing or boating in the pond and such. The year it was completed, super old, 1696. So that's impressive, Massachusetts. You can see how much water it stores in the reservoir. 866 acre feet. You can see information about its structure, like exactly how long it is, how high it is, um, all this stuff. One thing that's important is the inspection and evaluation. So this you can see in 2022 in August was the last time it was like formally assessed, and they found that its condition was fair. Um, Something that's interesting too is that uh, the inspection frequency is supposed to be, reviewed every 2 years. But you can see here it was last reviewed in 2022. Here we are in 2026. So it's behind schedule. So that could be an interesting thing to look at for a dam in your local area to sort of ask officials, why haven't you looked at this? It's been past its due time and on. It does have an emergency action plan, um, which was last revised in 2024. So that's good. Um, to look a little bit more broadly in Massachusetts, so if we go back to the main NID list, Massachusetts again, um, if you wanted to filter, so that was we're looking for a particular dam, but um, say we wanted to filter all of the dams in Massachusetts to find something specific. So we could look, for example, at all of the dams that are high hazard, so big enough to be dangerous. We could look at dams that do not have an emergency action plan, so that might raise a red flag. Um, and then you can add different filters this way. So I just added a filter for condition of the dam. So here I'm going to select unsatisfactory and poor. and update the results. And look, there's two dams that pop up. So the Riska Brook Dam and the Brierley Pond Dike, both of these now we know are high hazard dams that do not have an emergency action plan and that were rated in poor or unsatisfactory condition during their last inspection. Um, so we can see now, okay, so this dam, this is in Berkshire, Massachusetts. It looks like it's a private owner, the Groman Finnegan Realty Trust. Um, it was completed in 1952, so more than 70 years old. It's in poor condition uh, as of inspection in 2024, and it does not have an emergency action plan. So that could be an interesting dam to get in touch with dam safety officials or with this its owner, the Groman Finnegan Realty Trust, and say, why isn't there an emergency action plan? Why is the dam in poor condition? Is this something we need to be um, concerned about? So you can see how you can start to see how this would be really useful. Um, just to look a little bit more broadly, I'm going to take away the emergency action plan filter and also the high hazard filter and just look for dams in poor or unsatisfactory condition. So all of these yellow dots are all of the dams in Massachusetts that are in poor or unsatisfactory condition. There are 337 of them. Um, so all good leads for places to look, ones to look into further. Um, Another thing I wanted to show you all is so I mentioned that most emergency action plans for dams are, oh, sorry, gotta go to back to the. So most emergency action plans are not public. If you wanted to get them, if you can get them, if they exist, requires a Freedom of Information Act request. But some states have actually made them public. Just two states, as far as I know, South Carolina and California, both made the inundation maps public after major dam failures or scares. In California, that was the Oroville Dam, that photo I showed early on. In South Carolina, that was in 2015. There was a hurricane that caused more than 30 dams to collapse across the state. Or I should say fail, not collapse. And I'll show you what that looks like in California. So here, this map, which is put out by California Water, um, I'll zoom out a little bit, shows every single dam in California. And what's unique here is that you can zoom in, and if you click on one of the dams, it will show the inundation area if that dam were to fail. So here's the Comanche Dam. This looks like a large reservoir, and you can also see uh, it's just above the Central Valley, which is, pancake flat. This is up in the foothills of the Sierra Nevada. So it's a big reservoir looking over a flat area. It probably has a large inundation area. Let's see what happens. Um, There. Okay. Wow. So you can see this area that just generated is the area that would flood if that dam were to fail. That's a pretty large area. You can see on the left, this is the entire city of San Francisco. So it would flood an area larger than the city of San Francisco. Um, that would be a major disaster, of course. Um, I don't know if there's a conversation in Massachusetts at all about making inundation maps publicly available or more accessible in some way, but that could be a good step, both for safety purposes, but also to increase the visibility of dams. Um, so uh, it's worth saying this all sounds very scary, but dam failure is like quite a rare thing. It's not but it's not impossible. It does happen, as it shows in Michigan, South Carolina, California. This was a story just last week in the New York Times. Michigan's dam crisis shows decay of U.S. infrastructure, says Governor Gretchen Whitmer. Um, After a really heavy snowed winter, lots of flooding, lots of runoff. Another 100-year-old dam is near overtopping, sprouting leaks, one of thousands in the state that are in similar condition. So just posing a greater risk. And it really highlights how aging water infrastructure is increasingly meeting a changing climate and may not be prepared for those changes. It's sort of a combination of both just like regular aging, but also the climate is changing, creates new risks. The second headline is a story I wrote for New Scientist magazine about a year ago about how something called the probable maximum flood estimate, which drives a lot of like central engineering decisions about how infrastructure is built. Um, these estimates are increasingly out of date because they're based on historical statistics rather than weather statistics that project out ahead as things change. So that's a problem. Um, for me, one of the main takeaways of all this reporting is actually kind of simple. It's just we should pay more attention to dams. Um, I took this picture when I visited the Edenville Dam. This is in the drained reservoir. The video that you saw at the beginning, that is in the background. That used to be the dam holding back this big reservoir. Uh, and it's interesting because most dams are so old, they've been there for so long, 100 years. They've basically become invisible. Like all of the houses built around this reservoir, it's like they're built around a lake. The lake it becomes hard to see that the lake is actually something that we've constructed and kept there, and then suddenly everything changes. Um, but dams are pieces of infrastructure. These are like 90,000 plus interventions in the landscape. They're aging in need of upkeep or removal, at the very least, attention. I just saw that last week, actually, the reservoir that was behind the Sanford Dam in Michigan, they just started refilling it. So after 6 years, and having spent more than $200 million on repair, they're now starting to refill these reservoirs. This dam, the Edenville Dam, isn't expected to be repaired until next year. That I know has been a very contentious discussion for the community that used to live around these reservoirs, like whether to rebuild, how to raise money to rebuild. And it would have been much cheaper to repair the dam before it failed, or I bet probably to remove it too, if that was the decision that the community came to. Um, because it's Earth Day, I wanted to end on a bit more of a positive note than all our aging dams are at risk from climate change. So as you all well know, there are a lot of things that can be done about aging dams. You sometimes hear the three R's: rehabilitate, retrofit, remove. The importance of rehabilitation is really clear from this story in Michigan. One thing that I think hasn't got enough attention is this idea of retrofitting dams to generate hydropower. It's possible in some cases, not all dams by any stretch, to convert like a dam that's just used for flood control or recreation to also produce clean electricity, which could be a way of, turning this thing that might have been damaging to the environment into something that is producing a cleaner source of power without having to build a new dam. This picture is an example of a dam that was retrofitted in Iowa recently that now powers 18,000 homes. So before it was this Army Corps of Engineers dam that was just used for flood control. Now it's doing that, but it also is producing power. A few years ago, there was a report from the Department of Energy that estimated there's a potential for 12 gigawatts worth of retrofits out there, which is a lot of power. It's like enough to power millions of homes. If you were to, retrofit all of the dams that have potential there. I want to say that wouldn't mean retrofitting all dams, and it's also important to consider you wouldn't want to give a dam a new reason to exist if it was causing other problems. But retrofitting could be an option in some cases. And I'll share a story after I stop sharing slides that a detailed story I wrote about dam retrofits. And then the third are the removal. As you all well know, it's possible to remove dams, though often a big challenge. A recent project that really captured my imagination that you've probably heard about is these dam removals on the Klamath River in Oregon and Northern California. Often said like the biggest dam removal effort ever. It was completed last year. They took out four large hydroelectric dams. You can see this before and after picture, but I'm actually not sure which of the four dams this is, but this was the reservoir before it. After maybe a year later, you can see the river braiding through and the vegetation already starting to um, come back there. Some areas of the river have seen salmon return for the first time in a century. So it's an inspiring story in that way, and it was really a largely indigenous-led decades of activism effort to make that happen. Um, Almost as big a project as the dam removal itself has been restoring the area that was left bare of vegetation by the drained reservoir. So you can see what that looks like here. This is right after the reservoir was drained. Um, it's basically a bunch of mud. There's a lot of concern that invasive plants might move in, that this would cause other problems by leaving it open. So there's been this giant campaign funded by the states to cultivate literally billions of seeds from native plants in the region and spread them so they take root. So there's this whole effort of like collecting seeds from the native plants already growing along the river, bringing those seeds to a nursery in order to grow more seeds and then sow them across the area of the former reservoir. And this is what it looks like today, or this is a fairly recent picture, I think. So the river coming back, plants coming back. I think it's an inspiring image. Um, so thank you so much for listening. As Anna mentioned, if you'd like to stay in the loop about what I'm reporting on, largely now it has to do with broad questions about earth science, in particular the geology of the deep earth, which is different from dams, but they can be related in surprising ways. Um, the best way to stay in the loop is to sign up for my newsletter, which I'll put a link in the chat. And thank you, and happy to take questions.
Awesome. Thanks, everyone. If you have any questions, please go ahead and throw them in the chat. I see one already from Ariana. Um, and she asked, when dams are retrofitted, do they typically include fishways for passage as well? Do you know?
That's a great question. I don't know. So I don't know enough to say like if that is typically what happens or not. I know there has been a lot of work on trying to design hydroelectric turbines that are more fish friendly. Um, there are a few companies that are working on that, and I think I have had some success where the fish can actually swim through the turbine without being harmed. Um, um, and yeah, that is also another potential reason to retrofit a dam. You could combine a hydroelectric retrofit with a retrofit that might be beneficial for wildlife, and that might be a sort of win-win in some way. It could also help fund that sort of retrofit because if you're saying, okay, hydroelectric power could be produced now, maybe there would be a way to um, fund that sort of project, which can be really expensive.
Great, thank you. I also will say thank you to Matthew, who put a link. It seems like Vermont also, I haven't had a chance to look it up, but Vermont also might now have their inundation maps public.
Oh,
Um,
really? Okay, cool. That's good to know.
he sent a link in the chat to that as well as the California one that you shared. Um, I will also say for everyone, when we post this on YouTube, we'll throw in the links that James had shown for the different inventories and stuff like that so people can have access to those and take a look. Awesome. Yeah, opening it up. If anybody else has any other questions, happy to take them now. Okay, I'm not seeing any. Oh, let's see. Matthew just sent one. Matthew says, did you come across any states that require sediment sampling in the impoundment as part of their dam safety planning, that kind of emergency action plan?
Hmm. I have not seen any discussion of that in like emergency action plan situation. I know that that is often a concern at dams, especially as they get older. Sediment does start to build up behind them. And actually, uh, when people talk about contamination in dams, a lot of the time that is actually what they're talking about is the sediment that builds up behind the dam can itself become contaminated and with fertilizer that builds up other chemicals over the years and years. We didn't look at that at all. Our question was this sort of cascade effect. Could the flood release contamination downstream? But that could have been another thing to ask is there actually contaminated stuff behind the dam that could be released?
Absolutely. Yeah, I know that's something for our Dam Busters series that we get, as a common topic that people are interested in learning about because sediment management, sediment removal, if you have to take it out or cover it in some way, can just add, hundreds of thousands of millions of dollars to projects. So I know.
I know that the Klamath Dam case as well. Um, it there was an interesting dynamic where the removal of the dams ultimately seems to be really beneficial, but in the initial removal, the sediment that came down and also the water that actually like led to a very large fish kill in the river. There was something around changing dissolved oxygen in the water. I'm not sure of the details, but I thought that was an interesting dynamic where there's some risk, environmental risk to the effects of the removal itself in the short term.
Absolutely. Here's a question from Renee. Is there a niche subtopic within this space you haven't researched as much that you would want to explore next?
That is a great question. Um, well, uh, I am interested in a few things. I've heard about these ideas of sometimes they're called like micro turbines or like micro hydroelectric systems, where there are some ideas about how to produce power um, using existing water systems. So like on the water pipes carrying drinking water and stuff, a lot of times they have excess pressure, and it actually is possible to use that excess pressure to generate some like extra electricity. So that's not it's hydroelectricity, but it doesn't involve building a dam at all. Um, I think one of the biggest things in like hydropower world at the moment is something called pumped storage hydropower, which is by far the world's largest source of energy storage. I forget of long duration energy storage. It's something like 90% of current energy storage comes from you use surplus electricity to pump water up a hill, and then when that power is needed back, the water is released through a turbine. Um, and it's sort of the main source of like hydropower development in the United States at the moment. And so there's a lot of discussion about that because of the transition to more intermittent sources of electricity like wind and solar need a lot of energy storage. Pumped storage is something that can provide that. But it's interesting from a dam removal standpoint, I think, because a lot of people are thinking about ways to build pump storage systems that don't involve dams, like that are, that involve like building some sort of pond that's separate from a river system, for instance. Um, so that's another source of water-related development for sure that interacts in this really interesting way with the general transition away from fossil fuel power.
Great. Thank you. Thank you. Good question, Renee. She said, that's so cool. Thank you. This was great. Anyone else? Okay, if not, I just want to thank everyone for joining us for this Earth Day webinar. Thank you again, James. This was fantastic and such an interesting lens to take for this particular thing. The fact that you said that a lot of the officials that are in charge of reviewing the dams didn't necessarily make the connection between the potential risk to the Superfund sites and the dams is surprising to me, but a great opportunity. So I really appreciate you taking the time to kind of talk to our audience and share your piece with us and the work you did.
Of course, thank you so much for having me. Really appreciate it.
Thank you, everyone. Have a good rest of your day. Bye.